Good evening. Seems like tech is working fine. Yes, brilliant. Welcome everyone to another exciting Quantum London webinar. We are very happy today to run this one during the Digital Leaders Week. And we are also very excited because we have a great speaker today, and we will be talking about a topic which is very close to our heart, which is creating an ecosystem, how to link academia with the industry and the various business, quantum industries and the other businesses. Just a couple of words. I see there's a number of people that are new to this group, what we are, who we are, and what we're trying to achieve. So Quantum London is trying to join the dots and create some awareness and sharing some knowledge around what quantum computing and quantum technologies more in general are. And we are trying to do this from a business perspective. So there are great groups out there talking about these topics from a technical point of view, but we're trying to understand what are going to be the business implications of these technologies. When is this coming? When should we start worrying about it and looking at it carefully? And we know this is going to make a huge impact in some areas, but we also know that it's still not clear exactly what those areas are. And with this group, we are trying to answer all these questions and create also a community, joining the experts who might have some answers with, people that are curious but might have a business need, and join the two worlds. So today's topic, creating an ecosystem, is very close to what we're trying to achieve. So really happy to be talking about this today. And Paul, I don't know, do you want to add anything?
No, that's great. Thanks. I'll wrap up towards the end with some additional thoughts, but really looking forward to hearing from Sergio.
Brilliant. So I will let our speaker introduce himself. I will just say Sergio Gago, and he's a managing partner at the Quantum World Association. He's going to talk about what he's trying to achieve with his association around creating an ecosystem and his experience in this space. And he's also EVP technology at Naviga. So, Sergio, over to you.
All right, thank you. Thank you very much, Emmanuel and Paolo. Thank you very much. It's great to be here and be part as this kind of brotherhood between Quantum London and Quantum Barcelona, and use maybe the byproduct of this pandemic is that by doing everything global, we can sort of do these things online and mix and match our events and things like that together. So thank you for the kind introduction. As you said, my career has been in what I call now the classical world. In fact, my teams now hate me because every time I refer to the engineers who work with me, I call them classical developers, classical programmers, and it's not fair to them. But my career, I started as a software developer. And then slowly, maybe because I was not the best developer in the room, I moved over to management, to lead small teams, both in startups and then later on in corporate companies. I worked with Rakuten in the UK. It was Playco UK, you might remember. Then moved over to Jello Games and Senior, and then lastly with Naviga Global, where I'm the executive VP of technology, or global CTO, anyway you want to call it. But my career has been always precisely on that gap, trying to bridge the gap between the engineers, what technology can do, and what business needs. It's at the end of the day one of the many hats that chief technology officers do, and sit on the board, do these kind of things, but at the same time have one or two fingers in the actual technology, whether it is pure coding, big data, machine learning, artificial intelligence, and bring all these new things that the technology offers to solve problems that already exist. And thanks to that is why I enter in the quantum computing world since it started becoming more real than the theoretical basis that we had a decade ago, where it was great. We could go with all the algebra, with all the theory, But now where we can actually go and play with the qubits is when we can start doing real things. And that's what we're doing from the Quantum World Association, from Barcelona to the world, bringing these startups together with investors, with demand companies, and trying to build this ecosystem in the same way that you're doing.
So that's, I think, great starting point. Can you talk a bit more around, the importance of bridging these three worlds, the academia, the engineering, and the business?
Right. So the quantum computing world, since it's a new industry, not new, but relatively new if you compare to other fields, we have a huge impact from the theory side. At the end of the day, we have been able to do real things, to run our algorithms into actual quantum computers just for a couple of years, or a bit more depending on where you were. But it's really, really new. And everywhere you look, from the investment side to the research to the actual people building the startups, it's still a very small industry. In fact, we end up knowing each other on what we do. So in the same way that we had the engineering and technology world and the innovation by technology, and the business world, and plenty of tools to bridge these two together, and even with that, we are still struggling in some cases. In the quantum computing world, it's more like a triangle. So we have the technologists, we have the business and investors and demand companies who have lots of problems to solve. And then we have academia, research, and everything that comes from universities, colleges, and these places. And we are here thanks to them. We are here thanks to this research that is making better qubits every day, better coherence time every day, doing all these kind of new algorithms, trying to prove some advantage over the classical ones. But now there is one more step that we need to take. Number one is, how do we take all these pieces that have been either innovation or research, and how do we make this into something that we can sell? Whether it's consulting, a product that can scale, or hardware or sensors that we can take to the market. And then the third piece is, who's going to invest on that? And there are major differences here on how each of these vertices of the triangle works. The way you try to get grants on academia is very different than the way you build a go-to-market strategy, or you build a business case for a client, and definitely different than the way you raise capital with a private investor, regardless of whether you're looking for a seed capital round, or Series A, or B, or C, regardless on the stage. So you can have two things, right? You can either find someone who can swim freely between those three worlds, which is extremely difficult. There are people like that, and those are 1 in a million, really smart people who are PhDs and in theoretical physics and stuff like that, and they do their own research. Also capable of taking that research into something that can be sold as a product, but can also be developed, and then good enough so they can understand what a balance sheet is, or what a P&L is, and prepare a deck that an investor can understand. Although there are a few people in the world who can do that, typically what we find is that organizations that sit in the middle, supporting the three groups, can create a lot of value on the three sides of the triangle by bridging this gap.
I think that nicely into deep diving a bit into that specific topic. So how do you go about building a community independently and with some specific targets, and then get everyone together?
Right. So each of these targets typically is very good at getting together and creating value out of what they do. In academia, there's plenty of events, plenty of a community where the researchers and the scientists go to conferences and present their papers and present the results of their research, and they do quite well on that. Some people like it, some people don't like it, but at the end of the day, within their ecosystem, they do it quite well. At the same time, from the business perspective, investors have a vast network where they share resources, materials, deal flow, you name it. Depending on the investment horizons and their targets, they have a really decent network as well, and also in terms of the community they built. At the end of the day, they have been around for quite some time, and maybe the ones who were investing in digital 20 years ago and then went slowly into AI, ML, and other deep techs, today are the ones thinking on going into quantum computing. So the only thing they need is the external idea and training on, is this a thing for real, and where is my place in it? And on the technology side as well, there's plenty of conferences and events for machine learning or coding in general. You have in every major city, in London you have, in Barcelona we have Python camps, technology-specific meetups and communities that do precisely all that. But what's the common ground of all these three groups? The thing you find in each of these places is people from the same target. Developers and engineers of all kinds, or big data specialists of all kinds in this group, business people, VCs, and people in the economy side on these ones, and researchers on this other one. And in many cases, even happening at the very same time. So these communities are great, and they help a lot the industry move forward, but they do not necessarily create the required ecosystem that you need, putting all these three things together. And that is one of the things that we need to work on more and more, both from Quantum London and from other initiatives around the world. Now, how do you do that is a different question. What we're trying to do as from the Quantum World Association is be right in the middle of this triangle and create, number one, events that target each of these groups, but then leverage on the outputs of each one. So with demand companies, we get to know what are the actual problems that cannot be solved with today's technologies, or those things that companies have in the drawer or had in the drawer for a long time, especially in, I don't know, in finance or agro-tech. And there's not a real proper solution for that. And then we can go to the researchers and say, hey, do you have something that could relate to all this? Is any paper around that talks about this specific problem, or something that could be adapted to? Because what you will have is a bunch of algorithms that don't have a direct link to the problem or the solution. You will have, I don't know, a knapsack problem algorithm or a tabulated salesman problem. But how do you apply that specific algorithm into the domain of portfolio optimization for finance? That's a completely different story. And that's where the other group comes in. And then you say, all right, so you have this problem that you've been trying to solve with TensorFlow or machine learning in general, or with brute force approaches. What if you could have this technology that, granted, today is in baby diapers and you can only play with toy models, but in a year from now or in 2 years from now, you will be able to leverage further and your toy models. So creating those communities with these three types of people is what helps you leapfrogging to the next step.
Trying to create a virtuous cycle where all these three actors, they interact together and they're kind of in balance. So what you see at the moment, do you have this balance and you're just trying to make the wheel spin faster, or do you feel it's a bit unbalanced? Maybe it's a supply driven more than demand driven. What's your take on that?
So I actually got a similar question the other day. It was more direct, and what they asked me was, is quantum computing a technology looking for a problem to solve? And I think the answer is no, because the problems are there. We just don't have enough qubits to, or enough noisy-less qubits to solve these problems. But if I can think what is the biggest lack at the moment, besides the qubits, is the talent. That's what we lack today, and what we will lack massively in a few years from now. And the reason for that is that we're getting better and better at abstracting the theoretical layer, the pure physics and quantum mechanics layer. So in the past, you needed to have a lot of context on quantum mechanics, in order to understand what you're doing. But more and more, we're putting that in a black box, so you just use it. And we thank for that to the libraries that we have around, from Forest, from Brigade, Qiskit from IBM, Cirq from Google. All these libraries help you build your algorithms without needing to think about what's a bracket, what is the wave function, and all these kind of things. So with this work, what we're doing is separating those two fields. We will have academia and the researchers are still working on the basic need that we have today, from hardware to optimize algorithms and things like that, and that's definitely needed. But then we have this abstract layer on top that helps us put in these solutions on real-time scenarios. And we see that in chemistry, where we have specific libraries already on that, and in finance, where we have specific libraries on that. So back to your question, what we see is that the demand companies are waiting for us. They have all these needs and had these needs for a long time, and they have their domain specialists. So they have quants in finance, they have their chemists and chemistry engineers, chemical engineers in agro and in pharma, who know perfectly well the nature of their problem and how to map it and how to play with that. They've been doing that for years, but in a really cumbersome manner. In order to design a drug, you would design the molecule, you would drop that into a supercomputer, and maybe 1 week later you will get the results of your simulation. Probably it will be wrong, so you will have to do this again, rinse and repeat several times. And that's one of the many reasons why drug discovery takes a long time. And even with that, we have to simplify a lot all the parameters. So then is when quantum computing works. This specific profile that understands what quantum computing can bring into the table, but also has the domain knowledge, is where the magic happens. So more than saying where is the imbalance in the process, I say in the specific role of this person holding the domain knowledge, but also that we can train on how to get into quantum computing. And I think that's where the magic happens.
So the academia sounds from your words, and provides two different things. One is the research and pushing the limits and the new algorithms, but also providing the talent that the industry can use to spin everything up. And there is an interesting question here in the chat from Oi. Hi Sergio, when you see talent gap, what skills are you looking for? I don't see much jobs for domain specialists. So what do you think are the skill gaps, and also the academia trying for figures for?
So if you ask from the academia side, I think that, and I cannot speak for everyone, but I think that we still have a long way to go on the basic science behind. At the end of the day, it's still working on the hardware to go past the noise intermediate scale computing era that we are today. And there's plenty of say abstract or general research that we have to do on, from the actual qubits architecture and hardware to the many layers, all the way to the high level software on that sense. Now, from the business side, what I meant before is that the more and more we build these algorithms that help you, simulate a molecule using a quantum computer, is going to be more efficient to take a domain specialist, say in pharma, and train that person or that group of people in quantum computing and how to use a specific chemistry quantum simulation service, than take one person who's a quantum engineer and teach him or her all these specialties of pharma. Because at the end of the day, the person who's using the quantum algorithm to simulate a molecule in pharma is going to be one more step in the value chain of the drug design. So that's why I mean in that sense. And what we are saying, and at least in Spain, is that some companies are more willing to accept, say, I have this group of data scientists or this group of chemical engineers. How do we go about teaching them how to simulate stuff on a quantum computer. And you go from 2 weeks seminars or workshops or specific trainings from masters to postgrad courses, where you add this layer of knowledge to this group of people. I don't know if I answered the question.
Yes, thank you. So you mentioned Spain, which is where you are at the moment. So can you explain us a bit what's the situation there, and what steps have you taken so far, and the role your association is playing, and how this everything we discussed so far translates into more concrete actions?
So the Quantum World Association started about a bit more than 3 years ago. So our claim is that we are the first association in quantum computing in the world. I think that is true, but happy to get confronted of that. Nevertheless, it started extremely early. It started when there was barely any qubit available in the market that you could ping. Of course, IBM was already building their computers, but it all started because people were saying, "Hey, we have a quantum computer here, or we're building this one here," and everyone started. Well, their minds were exploding. Like, what do you mean? Wasn't this all pure algebra and quantum mechanics theory? No, but actually you can build it, and there is some good outlook on this. And maybe in 30 years or in 40 years, we will be able to talk further about this. So it all started very, very slow in that sense, about 3 years ago. But the more and more we advance, and probably as you have said, it's an exponential growth, both in the development of things, to the amount of investment and startups and research going on. This has really exploded. So the Quantum World Association was kind of at the epicenter of everything in Spain, because it was built by people from Barcelona mainly. But we wanted to do it, or at least the founders, I was not there at the beginning, wanted to make it international at the beginning. So actually 4 of the founding startups that created are from all around the world. One is from France, one is from the UK, another one is from Australia, the one is from Barcelona. So what happened was that we started seeing this organic growth because it just made sense. It was not a specific plan on how to do this. So some demand companies came to us and say, "Okay, we hear about this quantum computing thing. What is it about?" I'm talking about no more than 5 qubits, no more than 10 qubits being able to being simulated on a normal computer. So really early stage. But still, with these demand companies, we could see where the initial cases were happening, and that's where now it's very clear that finance and pharma are the the leading cases. But 3 years ago, it was not that clear. It was these demand companies who wanted to be on top of things. So our idea was, when this thing happens, because it's not a matter of how or where, it's a matter of when, because it will happen. Where do you want to be? A huge wave is coming. We don't know exactly when will be coming, but it's coming. Do you want to be on the water, and maybe you will get cold by the time it's the time to surf the wave? Do you want to be on the beach and start warming up, or do you want to be at home still having breakfast, and maybe the wave will be over and time to surf is over? So that was the idea at the beginning of the Quantum World Association, and then the company Entanglement Partners was created when we had the demand specific information on finance. Then there was a group of people who said, well, there's an opportunity here, and then multiverse computing was created, and so on and so forth. And we identified the need for training, as I've mentioned before. Okay, how do we tackle this lack of talent that we will have very, very soon? The other problem is, how do we manufacture bigger and better qubits? And since that's very capital intensive, we didn't want to get there, but at least on the training side, we could go for it. So we out of the association was created a Qubit Institute, and then at the same time, sorry, go ahead.
A lot to learn from, which brings me to my next question, which is twofold. So, do you see similar initiatives happening in different countries? Which I think the answer is yes. The reason we are all here around this visual table, that's clearly testimony of that. But more importantly, how do you see these ecosystems grow in the future? Is it going to be something international? Is it going to be local ecosystems which we eventually connect all together? What do you think is the trajectory there?
I think there's a space for both, and the beauty of it is that you can do both at the same time. That definitely there is going to be some consolidation on the international side, at least in the midterm, because that's what we have seen in other industries that are deep tech related, from artificial intelligence to self-driving cars and blockchain and whatnot. It tends to be just the cycle of the market, right? So at the beginning, everyone starts and gathers their network of people, their set of events, their partners, sponsors, and whatnot. But eventually, you either segment yourself or go big. And typically, the way to segment is by staying local, because with that, by staying local, you can leverage the community that you have around you. And then you can do the face-to-face events that are very important as well, at least when there is no limitations virus related. So I think the local ecosystem still needs to happen and needs to grow, especially when it comes to having a beer together with a researcher who's dealing with a new photonic qubit, with with an investor who's looking to put 3 million or 5 million into a couple of quantum computing companies, and someone who's a specialist in the go-to-market. Those relationships happen better with a beer in your hand. And then there's the international side. And at the end of the day, it's a nascent industry. We're not that many people. And that's good, because we can shape it as we want in a way. And this consolidation, I believe it will happen probably maybe in a year or two.
So thank you. I wanted to build on the point around investment. So, clearly any type of startup arena, whether it's, truly deep tech or whatever it may be, needs the money. And it would be good to dig a bit more. You've touched on a few times how you've met some of the investors, and some of them have been investing in sort of emerging tech for the past 20 years. But can you talk a little bit through how, beyond the first few you met, you've been encouraging additional VCs, especially maybe the more traditional ones that are more averse to deep tech? It'd be great to understand your thoughts, both what you've done, but also ideas of what, for example, we may be able to do in London and the UK. So
the first thing that we need to consider and have in mind is that all of us, and I assume the attendees to this event, we are somewhat versed in quantum computing, at least what it means, what it entails, and in which state we are. So we kind of have a somewhat decent definition of a qubit, what entanglement is, what superposition maybe is. But when you say these words to a muggle on quantum computer, if you allow me the term, their mind blows. Trying to explain superposition for the very first time to someone who's not in physics or who's not really into the field, I was like, what the hell are you talking about? And especially making the link between that and a business-related issue that we have. So the way we're trying to tackle this is by starting from a purely divulgative way. So basically saying what is in the business ecosystem in quantum computing, what is people doing, why people is investing now, and why do they think that this is going to be a thing. So the first thing I tell the investors, and we've been doing a roadshow around Spain and during this summer, trying to present the quantum investments branch of the Quantum World Association, has been, look, JP Morgan has created a team to work on this. Same as Merck, same as these other companies. Gartner says this, the Boston Consulting Group says this. So it's not just me coming to tell you this is the thing, is some other people who are quite smart think that there will be a time for investment. The second thing is being super clear and transparent. So forgive my word, but cutting out the bullshit out of what's going on. And this is extremely important. I cannot emphasize it enough. This industry, any nascent deep tech industries, is full of smoke and mirrors. Because if you don't understand what's behind, you can basically say anything you want about it. And not many people will be able to contradict you because either they're not in that room, or because they don't care, or because they cannot. So you will have here the quintessential claim of quantum computing will break the internet. And that's great to open the slide, but you need to go further and explain. So really say, look, today there is no such thing as quantum advantage. Today there is no problem that a classical solution, whether it's a classical computer, a neural network, a TensorFlow, anything you want, there's nothing that they cannot do that a quantum computer can do. However, and that's when you start talking about the growth of the ecosystem and how things are. So the purpose of that first session is to just educate them on what is going on and what is the signal, what's the noise. So you get the very first, you appear as a kind of a trusted advisor on that. Once they hear that, what happens is that now they have been primed into the concept. So they are more attentive to news on the industry. Some I don't know, when this company raises capital, it's like, oh wait, what type of qubit did Sergio say that this company was using, and does this make sense? Is this a VHAs versus Betamax kind of war? And then you go into the second session and go a bit more technical. And in that second session, I even try to show some quantum computing in action, to show them that it's not black magic, that it's just some Python and some circuits. And in some cases, they actually can follow the code itself. It's still a very low-tech, divulgative session. So I'm not saying that we are giving them a workshop in Cascade or in Penny Lane or anything like this, but we're showing them that, look, this is just Python code. And with this line of code, I'm just sending the computer to the IBM Q Experience or to D-Wave or to any of these companies that have free trials or free accounts up to some minutes. And look, I can factor the prime numbers up to 21. not much, but that's what it is. And then that concept of you need 1 million qubits to break the internet, it's better understood, because you follow this kind of path, and always with a hand on the business side, what's going on, why this is happening, and all that. Only when you do these steps is when you can go to them and say, hey, I have this startup who's led by a researcher. It's a spin-off of this laboratory or of this university, and they're looking for funding to do A, B, or C. We can, on one hand, help the startup on saying, okay, this is how you raise capital. This is how you build a go-to-market model. This is how you build a P&L. This is how you do a forecast. And this is how you build a team of advisors around you. So an investor, a VC, doesn't look at you like, where do you come from? And then you can go to the investor with all the work done. Because number one, they trust you as someone who knows what they're talking about. Not just your daily bullshit on quantum computing, but also who can do the due diligence and the curation of that deal flow. And it's a flywheel at the end of the day, where you have the contacts in academia doing this research or doing spin-offs from the research and creating companies. You have these data scientists who became quantum computing developers or engineers, and then you have the demand companies who have the need. Now, on the engineering side, what we're building is small communities as well, similar to this one, but maybe more on the technical side, who are focused on software engineers, classical developers, or big data practitioners who have this kind of transferable skills over to quantum computing. So once we have the 3 legs of our stool, we can see all the deals passing through and decide which ones have more interest.
Because you've got all of those people physically in Barcelona, or is it a Spanish-wide effort, or is it an international community?
I would say a big part of that is in Barcelona. and that's because a lot of our team is based here. We have our networks here, and yeah, our contacts are basically here, and that gives us a big starting point on that sense. It's international in the sense that we have companies, we have members of the association all over the world, and definitely the idea is to make it fully international and do partnerships and cooperations with people all around the world. And the good side of the pandemic is that this has teach people that remote working is definitely possible regardless of the environment. For most things in quantum computing, or for a lot of things in quantum computing, you can also work remotely. It's not that you need a clean lab or white lab to do all this, unless you're doing the qubits themselves. So a lot of the research can also be done at home. In fact, the amount of papers that have been published both in AI ML, but also in quantum computing has grown almost exponentially during the last 6 months. I believe the quantum computing part is because, of course, we're on the side of the curve. Let's see what happens in a few months. But what we see is that the amount of fields, of potential research fields on QC is branching out as well. Now it's not just talking about what kind of, I don't know, topological qubits research or anything like that. You can now do specific research on algorithms. You can do specific research on quantum machine learning and quantum neural networks and try to see if that's a thing or not. You can do research on the photonic side of the algorithm. So there's plenty of things to do.
So if you know, clearly, or not clearly, but so often the research is international with different universities collaborating and things like that. If we think about it from a funding point of view and where governments are coming from and where public money that's going into research is there a sort of a positive quantum arms race with every government wanting to invest more in their countries, or is it a sort of negative dynamic? What's your view there?
So I'm not sure if it's positive or negative. I would incline myself into positive, because the bridge between what's done in academia and what's done on the business side is really tied together. We're not talking about basic science where you do research just for the sake of research and advancing the overall knowledge of the human race. Any type of research or software you develop or algorithm that you develop will be there for the taking for any coming company. Now, when it comes from the public investment, at the end of the day, there's a political interest behind, whether it's the Quantum Gold Initiative, the UK initiative, the Quantum Flagship in the European Union, the whatever is going on in China. All these kind of things have a very specific political motivation. It can be taken as a defense mechanism, or a potential defense, because it obviously has this kind of potentiality, but also pure research and economic movement around that. We have already in the world some hubs defined, from Toronto, of course, the Silicon Valley. London is a really hot hub on quantum computing. The Netherlands in general have all the universities linked together in a really nice way. So there's plenty of places that are starting to pop up as potential main hubs or development centers. There has to be some consolidation where we specialized. Right? So I believe that Barcelona could be a really good hub for professionals. We have really good training centers and academic centers of really smart people coming from all over the world doing this research. But then how to move that over to business requirements? The line is very thick, it's very thin. So it's definitely positive on that side, and it's again a flywheel. It keeps feeding itself on that side, because the more we research, the more potential applications we could have, and the more excited the governments get, and the more funding you get. So as long as this will keeps going, and we have, again, the three things linked together, I think it's going to be positive.
Before we check into the Q&A, really is what does success look like for you and your association in sort of 18, 24 months time? What are your objectives? Where do you think it's all going?
So what I would like to accomplish next year is to make it really international and hit at least the 200, ideally 300 members, active members. Because one of the key things that we want to make is to not just be an association where we do work for the, at the end of the day, we're a nonprofit. So it's not that we do work for them, is that we build a network where they do things for them on that sense. And in this kind of industry that's starting and really picking up as we speak, it's really important that everyone comes with a given mindset and not a taken philosophy. Similar thing that we could see maybe 10, 50 years ago or 20 years ago in Silicon Valley, this kind of things where communities kind of grow organically on that sense. So we're trying to achieve that, make the cluster bigger and wider as well, or broader in terms of not just quantum computing, but perhaps also sensing and metering and hardware itself. And one of the things that we ask each member is, what can you do for the community? What you're going to do? Maybe you do training materials. So is that something that you can serve free to the rest of the members? Maybe you do simulation control software. Maybe that's something that you can offer at a lower price tag for the members. Maybe you do specific stuff for finance. I don't know, whatever it is for the members. How can you collaborate with your team members? How can you share your experience? Raising capital for the first time is not easy, or running a due diligence process for an M&A is not easy. So building this kind of network, I think really helps on that side. So my success case would be having something between 200 to 300 people by the end of next year, companies, I mean, but not just companies signing to become members, but active companies working and being dynamic in the ecosystem.
Perfect, excellent. And if there's anyone on this webinar or who's listening to it later who would want to get in touch, is it as straightforward as going to your website?
Yeah, absolutely. It's quantumwa.org.
Perfect. Okay. Thank you so much
I see someone saying QC is all about collaboration, and I couldn't agree more. It absolutely is exactly how we push things forward.
Cool. I think we might have lost your audio very briefly then. Do you want to repeat your statement on collaboration?
Yeah, sorry. I was saying, someone was saying on the chat that QC is all about collaboration, and I couldn't agree more. It's precisely that, how we share our neurons, our brains to push this industry further. I see one of the most beautiful things that I've seen, I think it was last week, now in archive where the papers gets published. Now there's a specific section where you publish the actual code of your experiments. And this is extremely important for reproducibility and also for learning, because it's not just reading a paper and figuring out what the hell is going on. It's also getting the algorithm and learning and making it yours as well. So absolutely, I see someone we have to put our brains in superposition. That's how you build things, by switching hats. Now I'm talking with my business CTO hat. Now I'm talking with my engineering hat, and back to coding in Python. And this collaboration is also international. So I see extremely positive that we do things together among all the communities in Toronto, in London, in Barcelona, in Berlin and Munich. The more we work together, the better outcomes we will have.
Now, one of the questions that often comes up in these discussions is, yeah, all fine about collaboration, but what's the risk of someone deciding they like using D-Wave technology, but actually Rigetti is going to be the winner, or IBM or someone? Now, presumably you can reassure us that the way the abstraction layers are working is that from a business point of view, we don't need to care whose box it's running on.
Right. That's actually the most typical question that you hear from VCs and investors in general. So is this the Betamax versus VHS war 10 times over? And in a way it is. And at the end of the day, I think that there will be one or two or maybe three winners on the actual hardware. Depending on the hardware, it's exactly what you said. Your algorithm will work the same, and it's just a matter of how you type it in Python or C# or your programming language of choice. It doesn't have to be exactly the same if you're talking about annealing computers versus gate-based computers, say IBM or versus D-Wave. That might be a bigger change. But in fact, what I believe is that we will still have annealers for quite some time for a specific type of problems, and then universal gate-based computers for the long term on doing more general case solutions. And that's a perfectly good case where you invest on what you have to, on the problems that you have at hand. One of the most beautiful things that we see today is that as you grow with qubits, there's almost nothing that you have to do on your program to change it. I did a test last week when the D-Wave Advantage came in. We have one algorithm to solving a typical root, optimal root solution, and the only thing I did was change the solver from the 2,000 qubits from D-Wave to the new 5,000 that they just released. I did nothing else, and suddenly I could embed a problem that was 3 times bigger with their hybrid solver and whatnot, and that was excellent. It's still a toy model, still not optimal, but this tells me is that as we grow, the changes that we will have to do are not exponential, neither linear. Are going to be we're going to have decreasing marginal costs on that side. Now, say that, could someone come from a dungeon saying, I found the perfect qubit, and it was not the topological, it was not the superconductor, it was not a photonic, it was not an annealer, it was something else. Could happen, absolutely, and we would have investors who have put a lot of money in Rigetti, in D-Wave, and other companies, and big corps who have also put a lot of money in their quantum computing divisions. Maybe pissed, but that's what the future will bring us, I think. And there's plenty of other. There's more than 14, I think, qubit implementations today, even though 2 or 3 of them are the top ones and the favorite ones, but still.
A couple of people have mentioned in the chat, in fact, the Fujitsu statement about 1 million qubit annealer. Is your sense that someone might come out of that dungeon with, being 5 or 10 years ahead of everyone else, or is it going to be a slow slog with the usual names?
I always think that history tends to repeat itself. And my personal belief, and this is a belief, not anything that I can back with data, but my personal belief is that we will have something similar than what happened with classical computers. So maybe in 20 years from now, someone will make a movie like Pirates of Silicon Valley, Pirates of Toronto Valley, or something like that, where we would have our version of Steve Jobs and our version of Bill Gates and our version of Xerox and IBM. And with who was the black swan that came with this qubit. I think that when we get to the 1 million qubits or the 5 million qubits or to the next stage, it will be something else or a version of what we have today. We had the IonQ saying that they will achieve a QPU in a desktop computer in 5 years, right? That's a bold claim. But can it happen? Yes, it definitely can happen, depending on how much effort we put into it. And we as humans have demonstrated ourselves to be stubborn, and that's beautiful. So, and the other funny thing is, IBM said, when was it, about 60 years ago, there's probably a need for 5 computers in the world, right? And there's no way that every house will have a computer. And now they're saying the same thing. There's probably no need for a quantum computer in every house, and you will have big quantum units in the cloud doing specific problems. And that idea makes sense today, and it really resonates with the information that we have. but I cannot see the future. The only thing I can see is that we humans are stubborn and get our way through one way or another. So I definitely believe on a kind of black swan coming up.
Brilliant. And then the last question from me, and then Em might have a couple of others, and then we'll wrap up. But the other main topic really we're here trying to solve is when it comes to engaging with CEOs, CROs, CFOs, board members of ordinary companies, what point should someone sitting in an insurance firm or sitting in an airline company or sitting in a supermarket organization, should they be thinking about this, and how would you bring that topic to their table?
So I think the very first problem to tackle is the expectations. You have to make clear that the expectations are not, we're going to solve this problem for good, because that's not the case. This has to be the analogy that I said before. The best wave in the world for surfing is coming to your beach. Now, where do you want to be when that wave comes? Do you want to be in the water? Do you want to be in the beach? Or do you want to be at your house just waiting for it, and then it will pass? I think that's the speech that resonates with a handful of CEOs. Not everyone, because not everyone is willing to invest on something that doesn't have a very specific horizon in there. And not a lot of companies are suffering today. So it's also another thing to consider. But when you compare with what other companies are doing in the US and other countries, it kind of resonates with them. It's like, well, these guys are doing something. What would be? So the typical way to get into this is integrate quantum computing into one of their departments. It's not saying I'm going to create a new division for you to do this. It's saying, okay, what is the team that's working with, if you're in finance, for example, with risk profiling or know your customer type of things, or insurance as well? What is the team that's working on the theoretical side of the risk and premium calculation? And what are they doing today? And probably they're doing some cool stuff with building models and creating data, and maybe using some machine learning for some unsupervised or supervised machine learning models to that, and maybe using some of those in production. And that came from something. At some point, maybe 15 years ago, they started building some models, and they were failing completely because we didn't have the computing power, because they didn't know how to do it, because nobody knew how to do it exactly. We were experimenting. So it's all about relate to that previous stage. What did you do when you started digitalizing your company? What did you do when you started using machine learning into your companies? And what do you do when you need to tackle this problem before your competitors? So the good thing of finance is that plenty of banks are now into this. The good thing of pharma is that plenty of companies in the industry are doing some simulation with that. So that's a starting point. But it all starts from R&D. There cannot be. It's not a revenue center or a profit center. It's a cost center pure for experimentation. For whenever the time comes to say, hey, now this works, it goes full steam on. And the second point is PR. One of the things that they might be interested in is being in the news saying, company XYZ, first one in the industry, using a quantum computer to solve this problem. Solve this problem is obviously not the case, but that's a very important point, especially in big companies.
Brilliant, thank you. And I think then the final question in the chat, Paul was asking again about the main geographic quantum clusters. So you ran through that very quickly: Toronto, Silicon Valley, London, etc. Do you maybe want to go into a tiny bit more detail and repeat the main places that people should be keeping an eye on?
All right. So my personal bet for what is or what will become the Silicon Valley of the quantum computing will be Toronto. Not only because the biggest private investment started there and is still there, and with D-Wave leading the pack, but also the research community and all the events and all the meetups and all the same triangle that we were talking about, I think is happening there. There's the Destruction Lab in there. That's an accelerator for this kind of things that works really well, and it's also pushing the boundaries on that side. The Bay Area is, of course, the other big contendant, because at the end of the day, pretty much all the tech companies are there, and a lot of the talent, both in classical engineering, is there. So you get the same ecosystem, even though it's still fully focused on what the FANGs do. So that's why I think Toronto got the advantage. And then everything else in the world came from academia, because the researchers are the ones who have started this and put this in movement. And in Barcelona, we have the ICFO laboratory, which is worldly renowned in photonic technology and this area. And this means that we have top-level researchers and PhD students and doctors doing lots of stuff in there. So it's just natural that companies branch off from there. And when this happens, it's natural that investors start looking about that. And it's just natural that when this happens, you get the ecosystem growing in a pure organic way. So the same happened in Munich, where there's a really nice community as well. And of course, the same happens in London, in the same way that happened with the AI/ML community and all the time, the blockchain community, that we're following lead at the end of the day.
And China always comes up as one of those interesting questions. How much is really going on there that we understand versus very secretive?
Honestly, not a lot of stuff comes out, except the private part, like from Tencent and Alibaba. And we know that the investment that each of these companies is doing is much bigger than everything that the European Union is putting together as a whole. So our numbers are minimum compared with what they are doing. But this actually applies to the whole area of research. It's not only about quantum computing, but also quantum communication. We have the devices that reach 150 kilometers for quantum key distribution, and then they just publish, hey, we can do 1,000 kilometers over the air with a satellite, right? But no one saw a paper, no one saw anything in that area prior to that. So it's really secretive. Maybe that black swan on the actual qubit implementation could come from there, or maybe not. But it's really difficult to get a hold on what's going on, except from what happens on the private companies.
Perfect. Well, thank you. I think we'll wrap up in a moment. Em, was there anything more from you before I close up?
Questions. I was just pleased to see so many good interactions in the chat, and this is all about collaboration, as someone was mentioning. So I'm glad to see there's so many new connections being formed in the chat tonight.
Absolutely, and I think we covered most of them. For those we didn't, we'll either stick them on LinkedIn or in Quora or somewhere where we can carry on getting answers. What I'd also love to do for some of the questions that came up, and also what I saw in the chat were mentions around a potential ecosystem in London around master's degrees and things. We do have a what we call a quantum Stammtisch event on October the 27th. That's just a fancy German word for having a chat. So at 6 o'clock UK time on Tuesday, the 27th of October, we'll be discussing a number of topics, including some of the ones that came up today as a result of Sergio's information. So look forward to speaking to some of you then. That's a fully interactive session, not just a presenter, so you can all get involved there. So I think nothing remains to say other than please, yes, as a community, keep engaged, post, comment, respond. That's really helpful for keeping the conversation going. And thank you to our presenter and speaker, Sergio Gago, from the Quantum World Association. We really appreciate your insight and look forward to keeping in touch over the months and years ahead.
Thank you very much.
Thank you.
Okay. Good night, everyone. Thank you.
Good night.